Hi there, coding fans. This is TexasTim.dev, and welcome back to my ongoing project to grind through all the problems on LeetCode. Well, all the algorithm problems anyway. So without further ado, let's get started. Let's see. Problems. Algorithms. Ones I haven't done yet. And I have done almost all the easy. At one point I had done them all, and then sometimes they pop new ones in there. But why don't we do a medium today? And we'll sort it from most accepted to least, under the idea that if it was accepted by a high percentage of coders, then it's probably an easier problem within the medium category. And we'll just keep increasing in difficulty as we go. Let's see. For this video, how about we not do the very top one, but let's do this one, generate parentheses, that has a really high frequency. I bet that would be much more interesting. Let's take a look. Number 22. Generate parentheses. And wow, look at that. Almost 9,000 thumbs up and just like 400 thumbs down. This is a well-liked problem. Given n pairs of parentheses, write a function to generate all combinations of well-formed parentheses. Oh man. When I saw parentheses, I thought, oh good, I'll use a stack structure, right? And then as I continued the sentence, I thought, oh, I don't know what I'm going to do with this one. So for example, n of 3. Oh my goodness. Oh boy. At least it's only up to 8. What's funny to me is there are only 8 possible valid return values, because n is going to be from 1 through 8. I suppose an enterprising cheater could just craft the 8 responses and return the appropriate list of string for the value of n input, but what's the fun in that? That wouldn't be any fun. Well, let's think about how we can represent these combinations, and maybe that'll lead to a better understanding of how to create the representation. So if we have one pair of parentheses, then if we have a second pair of parentheses, that can either be inside that first pair or it can follow. It can be subsequent. It can come after it. And so maybe by kind of working through all the possibilities of either putting the next one into it, putting the next one into the current one, or putting the next one after it, we can we can come up with all these. Man, part of me wishes that I would prep ahead of time so I could sound smart, but I don't, and so I come on these and it's really from a blank slate. Well, so if each subsequent nested pair of parentheses can either be in or after, then the number of combinations, I think, would be 2 to the n minus 1. Because if there's one pair of parentheses, if n equals 1, then there's only one result. So n minus 1, 0, 2 to the 0 would be 1. If there are 2, then there are 2 results, either nested or adjacent. If there are 3, then we can see in the example here that 1, 2, 3, 4, 5. Wait, 5? That doesn't follow the little pattern I was hoping for. Oh, because there are a few more. There are more than that. Because it's not just the next one could go in or after. It could also go outside any of the previous levels that have been created. I want to see what the size is for n equals 8. I think that'll work. I mean, so expected all those, and how many is all those? Let's get a, ooh. Well, it's not as many as I thought it was going to be. Yeah, that's not so bad. Oh no, there's 3 dots. Oh my goodness. Oh my goodness. So it really could be huge. Oh boy, I am really stuck on this one. I've been trucking through the mediums without too much trouble, and now having trouble getting even started here. And we're 10 minutes in. I don't have any code. What's the story? Well, maybe we could think of it recursively. The solution for n equals 2 would be the solution for n equals 1. Let's take a look at some of the, whoops, if I can type. Let's see, so for n equals 1, the solution is going to be just that guy. For n equals 2, it's going to be this or that, right? For n equals 3, oops, it's going to be that one, and then that one, and then that one. Well, so from n equals 1 to n equals 2, we add the new pair of parentheses. We either put it after, I guess we would put it after every, combination in the previous round. So after every closing parenthesis, we would insert the closed pair. So that's one way that we would obtain the result for the n plus 1 problem. So we've added it after, then we added it in. Here we add it after, and then we add it so here we add it after. And then we add it inside each closed pair. So after, and I'm thinking I would want to accumulate the solutions for each n in a set, because I think that there are going to be combinations that look like each other even if they were formed in different ways. You know, for example, going from 2 closed parentheses, if I add another closed pair after them all, well, now I have 3 closed pair. But if I add a closed pair after the first closed pair, then it again looks like I've got 3 closed pairs. So I'm thinking a set of string to accumulate the possibilities of the combinations. The drawback, of course, is that if my algorithm is producing a lot of duplicates, then it may not be very efficient compared to a solution that may be more mathematical and is just producing the exact combinations from scratch. Maybe there's a way to think about modeling these parentheses using numbers. So for n equals 1, if we think of each nesting of a parenthesis as adding height, then the tallest combination for a given n would be height of 1, because it would just be one closed pair. For n equals 2, we could have, like here we could have 1, 1, so that's 2 closed pairs, or we could have 2. And here we could have 1, 1, 1, or this would be 3. This would be 2, 1. This would be 1, 2. And this one breaks my breaks my system, because it's oh man. Yeah, this, I don't know how you'd represent this one in that way. One, 2, 3, and yeah, for n equals 6, we'd have to have something like that. So this here Man, this is a hard one for me, and yet look, so many people give it a thumbs up. My goodness, this is just hitting me right where I don't know. All combinations. Well, let's look at it maybe another way. If n is 3, then it could be at most 3 closed pairs. Maybe there's like a recursive. I'm really grasping at straws here. All right. Well, I don't want to just, spend half an hour beating my head against a wall. So let's look at the discussion. Backtracking. Nice. And recursive. Look, there's all these dynamic programming. There's all these lovely solutions. Let's pick one. And I always like to come up with the solution. Obviously, that would be what people like to do, is to figure it out. But since I'm having a lot of trouble here, I'm gonna look at this solution here, or the description, and then code it myself. So the idea here is to only add open paren and closed paren that we know will guarantee us a solution. Once we add an open paren, we will then discard it. That did not clarify it for me. The goal is to print a string of parentheses in a certain order. The length of the string is 2n. Well, that's handy to be aware of. The constraints are that the open parens need to match the closed parens. Without constraints, we simply print out open paren or closed paren until the length hits n. So here they're doing a recursive. And the backtracking, Okay, let's look at the code itself. Let's look at this person's. Look at how short it is. Here I am, you know, straining to find anything, and the answer is just a few lines. All right. So that's what we're gonna return. Yeah. It's got a recursive function. Passing down the list. Here's the starting point. And we pass down the number of open and the number of close. Interesting. Here's the real key here for this recursion. If open is less than max, what is max is n, okay? Then do an open. If close is less than open, then do a close. If close is the same as open, then don't do a close. We'd get too many closes, and close will never be greater than open at any point. Okay. So recursive. Let's try it. Let's try it. Oh my goodness, this could be a disaster. All right. I like to put, if I have a data structure that's going to be used in a couple different methods, then I like to put it out here. And we don't need the overhead of an array list. A linked list will work just fine. And this is what will return. And then we'll need our helper function, which is a void because we're going to directly work with the list string. And so what we will pass in, and actually we could put the n out here too. And then actually let's initialize this in here too. Okay. And now we just have to pass down the string so far for that particular pathway of the recursive function and the number of open parens in that string and the number of closed parens. Okay. So string so far, and then the number of opens and the number of closes. And as with any recursive function, we have our base case and our recursive case. So our base case, if, oops, I should put it in here. If, oh, that's what's happening. I was wondering why things were disappearing. My insert key got knocked off. Okay, so if so far length equals n. I have a new keyboard, that's what I'm blaming it on. Then we can add so far there and then just return. So that's our base case. We do not recur or recurse any deeper once the length is n. And then we actually have two recursive cases. And this is me trying to understand it, not just repeat back what I saw, 5 minutes ago. So there are two possibilities when it comes to building our string. We can either add an open parenthesis, or open parenthesis, I guess it is, or we can add a close parenthesis. Actually, before I forget, I do know that's going to be up here. So the string is going to be empty string, 0 opens, 0 closes. Okay. All right, so two possible recursive cases, adding an open parenthesis or adding a closed one. We add an open parenthesis if we have not yet used all the open parentheses that we have to use, which is going to be n. So there's n pairs, which means there's n opens and n closes. So if the opens that is for this particular call of the recursive function, if opens is less than n, then let's add an open to the end. So far plus open, and then that will be one more opens, and then we'll just continue to pass down the number of closes. So this is case one. Well, it's not really, let's not enumerate them. Case, add an open parenthesis. And here, case, add an closed or close parenthesis. Okay. When do we add a closed parenthesis? We want to try adding a closed parenthesis we want to do it anytime we can, because this recursion, we're trying to generate every possibility. So it's almost more a case of when should we not add a closed parenthesis. So we should not add a closed parenthesis if that would mean there were more closed parentheses than opens at that location in the string so far. So if closes is less than opens, then we can add that's funny. If closes is less than opens, then sure, we can add a closed parenthesis. So let's do that. Helper, and this would be so far plus close parenthesis, pass in the same number of opens but one more closes. All right, man, this is this solution here, with the recursion and the two cases and checking to see these constraints, checking to see whether we can add an open or a close, which actually, what's funny is I'm seeing if the length so far is n. Oh no, that's not. It's the. Oh, that's so funny. It actually wouldn't even. Well, that's fine. If the length is twice n, because there's going to be n opens and n closes, so it's when the length is twice n that we know we've completed a particular combination. Okay. So here it is true, as long as the opens is less than n, because once we hit n opens, that's all the opens. Now we could have there's a pathway in this recursion where we've added an open every single time. It's the path, you know, that branches off this first if. So in that case, if n is 8, then we'll hit a point where we have 8 opens. And no, you know, on this path we haven't added any closes. So n is 8. We're looking for a string 16 characters long. We're only 8 characters in. Every single one of them is an open parenthesis. So if we can't add any more opens, because opens is now equal to n. So it's gonna, you know, this first if block is gonna not, what would you say? It's not gonna happen. But since closes at that point would be 0 and opens would be 8, then yeah, the next 8, you know, there's 8 more closes that are definitely gonna happen. All right, I think this will work. Why don't we run it and see? Wrong. What happened? Okay, let's see what's going on here. I only did 1 so far length is twice n opens what if we do 2? Still, it only does that first one. Let's see. So we did an open, a closed, a closed. So far length is twice. And by the way, for so far length, we also could check whether opens plus closes equals twice n. That would also work as a condition to determine if we reach the base case. Results add so far. Opens is less. That's very, very odd. Well, as is often helpful, why don't we debug? Let's debug. Here's the debugger. All right, we'll get an entry point there. N is 2. Let's keep going. This is a little taking up a lot of room there. Maybe I guess I can shrink that a little bit. Still semi-legible. All right, let's keep going. Oh, return results. Helper only went one time? Oh, I have to, okay. I was doing step over, but I want to step into that one. So let's debug again. Okay, stop. Let's debug. I usually do step over every time. It's a little new to me to step into. There we go. So far is an empty string, and we passed in 0 opens and 0 closes. So let's and opens is less than n for sure. So we do go in there. Let's step into there. Let's see what so far is. Okay. Well, we know it produced 1. I mean, it produced 1 combination. It's just it shouldn't have stopped there. So that's correct. 1. We have 1 opens. Yep. And here opens is Still less. So we're going to go into here. And let's step into here too. So far. I think I'm going to keep clicking. Okay, so it skipped that if. Okay, it seemed. Okay. With the debugger, I'm not sure how it is going to jump around, because we're going to start having multiple calls to helper kind of in play, nested. And I feel like we missed one. We should have done one where it was open and then a closed. And so far we just have open, open. So that one's going to fail because opens is equal to n. This one should not fail. And let's step in here because we need to get the other one. And actually that will occur. This one just returns. Where did I pop out? Popped out. And that's gonna okay. That doesn't seem right. Let's step into this. Oh, okay. Oh, okay. Here's the one I'm looking for. Ah, look at this. Look at this. This has that opens should not. Oh, okay. I see what happened. I am an idiot. So within this context, I increment opens. And so then when it hits this second if block, opens is greater. That's not what I should do. I should pass in an incremented value, but not increment the value, because then it'll mess it up for the subsequent calls. All right, so this should work. There we go. Oh my goodness. Let's submit it. Let's see what we got. 1 millisecond. I can't claim a lot of credit because, as you know, I got help. But it is nice to complete a solution and to kind of understand what went into it. Thanks for coming along for the ride. If you toughed it out through those first 15 minutes when I got no coding accomplished, thank you very much. Feel free to hit subscribe and like if you want to follow along on my journey. And as always, if you have any comments or questions or want to dig in a little bit deeper or see something else interesting, feel free to pop it down in the comments below. Thank you so much. Have a good one. Bye-bye.